let's just recap a little bit of what we did yesterday. We were talking mainly about that, what radians and degrees, how to convert them, and how much is pi radians. That's what we really focused on yesterday. That we see it right here on this x and y axis, is that pi radians, this little pi radians right here, is equal to 180 degrees. It's halfway around our circle. Basically what that means is it's 3.14 radius lengths that will get you there. Okay, so if you look at this radius right here, you would have to do a radius here, that'd be like 1 radius, another one up here, that would be like 2, another one here, that'd be like 3, and this would be your 0.14 right here. So you'd have 3.14. Now you don't see it. So I just was recapping from yesterday. So 3.14 radius lengths will get you halfway around. That's what we were talking about. That works in every circle. I don't know if you know this, but how they actually came up with pi. How did they come up with pi? 3.14159, it keeps going forever. How did they come up with that number? They noticed that in any circle you picked, could have been really small, could have been huge. If you took a tape measure and measured around this circumference, and then you measured through the center and got the diameter, if you took the circumference and you divided it by its diameter, it always came out to be pi. Always, 3.1415. Didn't care if it's a humongous circle or a tiny circle. Your circumference divided by your diameter was pi. So in this case, we now know that since our circumference was 2 pi radians, that's our formula, we know that half of that circumference is 1 pi radians. So half of it is 1 pi, which is half a circle. Now I want you to look at the quadrants. So this would be like 1 radian right here. That angle, if I drew it like this, that'd be like 1 radian angle. It would also be 57.3 degrees. We talked about that yesterday. That's 1 radian. If I was to ask you what quadrant would 4 radians be in? What quadrant would 4 radians be in? It would be in the 3rd quadrant, right? Because this is 3 radians to here. 4 radians is about here. 5 radians, and then we got 6 radians, and then you got 0.28 is this last part, because 6.28 is your 2 pi. So this is like 4, radians would be in like this angle right here, would be like 4 radians. Okay, so just kind of, they're going to have some questions on your homework where you're going to have to find out what quadrant something is in. Is it in the 1st quadrant? Anything between 0 and half of a pi. That doesn't mean half a radian. Half of a radian is like right in here. This is like 0.5 radians. This is half of a 3.14, right? This is like 1.57 radians. Okay, it's half of a pi. You could also write this as 1/2 pi. If you like it better that way, write it that way. It's not half a radian, it's half of a pi radians. It's half of a circle. So if it's between a half and 1 pi's, then it's going to be in quadrant 2. If it's between 1 pi and 1.5 pi's, this right here is the same as 1.5 pi. So that's the same. 3 halves is the same as 1.5 pi's. So you go halfway around, that's 1 pi, and then you got 1.5 pi's to here, and then you get all the way around to here, you got 2 pi's. So just recapping, when we get to the unit circle in the next couple of days, you'll even see more of these. It'll make more sense, I think. All right, let's look at what they've got here. These are some of our common angles, some of our most common ones. And we converted them yesterday. So if I was to take 30 degrees and convert it to radians, you would have converted it to pi over 6 radians. You would have taken that 30 degrees and you would have multiplied it by pi over 180, because that's what we were converting yesterday. And the 30 goes into 180 6 times. So pi over 6 was our radian answer. And you can kind of see it with this picture. Look at the picture itself. You've got a 180 degree arc here, Okay, that means it's 180 degrees or it's pi, and it's broken up into 6 30-degree angles. So that pi is broken up into 6 equal pieces. So pi over 6, 1/60. Each piece is 1/6. Same thing with 45. 45 degrees, this could be a 45-degree angle, then there's another 45, there's another 45, there's another 45. There's 4 of these 45-degree angles that go into this half a circle, into 180, which is the same as pi. So look at it this way. If I took pi, or 180 equals pi, and I divided both sides by 4, just to keep it equal, 180 divided by 4 would be your 45, and pi over 4 would be your radians right there, pi over 4 radians. So I just took my conversion ratio and I divided both sides by 4. Or I could have divided both sides by 6 to get the first one. Or I could divide them both sides by 3 because there's 3 angles in pi over 3. 90 degrees is half a pi. If you'd rather put 1/2 pi, you can do that. It's half of a pi. Pi over 2 means half of a pi. 270 is what kind of angle? Do you remember what we called that angle yesterday? A new angle that we learned? Reflex angle. Yeah, it's going up and around. It's more than 180. So that's a reflex angle, and it's 1.5 pi's. So 1 pi would be the halfway point, and then 1.5 pi's is down here. 1.5 pi's, not 1.5 radians. 1.5 pi's, because you've got pi radians to get you here. That's 3.14 radians. So this is going to be about 1.5 radians. I'm thinking it's going to be about probably, let's see, 3.144. It's going to be near 5 radians. I mean, near 5. 6 is going to be over in this area, and then you got your 0.28. And then 360 we know to be 2 pi. So our 360 is like your circumference, right? Remember our circumference was 360? And that is the same thing as 2 pi radians. So that's our circumference formula. C equals 2 pi r. C equals 2 pi radians. It's 2 pi radians to get around the circle. So that was those common angles. Just wanted to see those common ones. Coterminal angles are going to be on your homework tonight. Coterminal. So I want to show you them with a little animation here. So let me show you what coterminal angles are. Let me start with angle A at like 30 degrees. If I can get it to stop there, it's 30. Okay, so you see 30? Let me go to angle D now. For some reason it won't let me get it exactly. Okay, there we go. And let's go all the way around and then stop at the same line. Okay, now do you notice that it now just says that these two angles are coterminal? What do those two angles have in common? They're in the exact same position. Think about it. Do they both start at 0? Did they both start where C is? Yes. Did they both end on the same line? What's the difference between them? One went all the way around. Okay, so what's the difference of their numbers? 360, which is one rotation, isn't it? Didn't we do one rotation difference? So coterminal angles are going to be angles that are looking identical. This angle 30 degrees looks the same as 390, except 390 went around one extra rotation. Let me show you something else, if I can get this to move. Let's go around another turn. And guess what happens when I lay that on top? What does that say now again? Coterminal again. They look identical, but now what happened? Another rotation. Another 360 degrees. So now how far apart are they? 750 minus 30? 720. 2 circles apart. Now they're 2 circles apart. Okay, but watch this now. This is where it gets a little tricky for you guys. I always forget that I can't. Okay, that's not the one I wanted to move. I wanted to move the other one. Okay, so let's say I come back around. Oh, it's red now. It's negative. And let's land right on top. Now what? Does it still say coterminal?
Yes.
Yeah, they still start at C, don't they?
Yeah.
They still end at where A and D are?
Yeah.
But one went one way, one went the other. How far apart are they now?
Negative.
No, it's still 360.
Chris is right. It's still 360. How do you figure out how far apart something is? You subtract them. If I was to take 30 degrees and subtract negative 330 degrees,
You add
how far apart are they? They're still 360 apart. You add them, you get double negative, you got to add. So those are still a rotation apart. So if we're talking about degrees, we're going to add 360 to make a coterminal angle, or add another 360, or subtract the 360. What about radians, though? What would I add in radians to make a coterminal angle? What's a circle in radians? What's one rotation? 2 pi. You're going to add 2 pi instead of 360. Just keep adding 2 pi and you get to do the same thing. So let's look back here at the notes. Here's coterminal angles. I mean, I showed it to you, so you can write what you want to write. I wrote up here what it was. Angles with the same initial and terminal points. What that means is they have the same start and they have the same end. Initial and terminal sides. Same beginning, same end. They look the same, but they have different rotations. So basically angles that look the same but have a different rotation. Now let's look at this example down here near the bottom. They wanted you to find a coterminal angle for pi over 6. So they're saying that this angle right here is pi over 6 radians. And they want an angle that looks the same but goes one extra time around. So this is pi over 6 from here to here. They want one that goes around and goes to here. And that angle they're telling you is 13 pi over 6. How'd they get that? Okay, what did they add? And what does 2 pi represent? One rotation. 2 pi is one rotation. Could I have added 3 pi? No, because that's 1.5 rotations. That's not going to end in the same place. Could I have added 4 pi? Yeah, because that would end in the same place. That's 2 full rotations. So you can only add even numbers of pi because those are your full rotations. Now, how did they get 13 pi over 6? So if they take pi over 6 and add 2 pi and put a 1 under it, what do you have to do there to add those fractions? You need a common denominator. So I'm going to have to multiply the second one by 6. So that's going to give me 12 pi over 6. So now I can add my 1 pi over 6 with my 12 pi over 6. That's how they got 13 pi over 6 radians. So that angle, when you went all the way around over here, that angle was 13 pi over 6 radians. It was more than a circle. 13 over 6 is more than 2. So it's more than 2 pi. So it's around. So you would say that these two angles are coterminal. Those two angles right there are in the exact same position. They're going to both start at 0 and they're going to both end where that pi over 6 angle is. They're going to both end in that same place. So that's what coterminal. Now, in the next example, they want you to find a positive and a negative coterminal angle for those two angles. So they want you to find one positive and one negative coterminal angle. Okay, so let's see if we can do that for the 3 pi over 4. To get a positive angle, we're just going to add a rotation. Add a counterclockwise rotation. That would be adding 2 pi. Remember, you have these on the link is on Classroom if you're needing anything. The link is there. So we're going to add 2 pi. Now I need to put a 1 under it because we're going to need a common denominator. And so 4 looks like a good common denominator. So that's going to give me 8 pi over 4. So if I have 3 pi over 4 and I'm going to add it to 8 pi over 4, I'm going to get 11 pi over 4. That would be a positive coterminal angle. These two right here, coterminal. They will end and start at the same place. But what do you think I'm going to do to get a negative angle? I'm going to subtract the 2 pi. I'm going to take a rotation away from it. So 3 pi over 4 minus 2 pi. I'm going to change it to 8 pi over 4 again because I already knew that from the first one. That 2 pi is the same as 8 pi over 4. And when I subtract these two, 3 pi minus 8 pi, that's going to give me a negative 5 pi over 4. Those are still coterminal. So coterminal angles, they start and they end in the same place. The two angles that I connected would look identical. Yes.
So no matter what the fraction is, we're always going to add or subtract the 8 pi?
2 pi or 4 pi or 6 pi or 8 pi, any even number, because those are full rotations. Those are all the way around the circle. You can't do a 3 pi or a 5 pi because those are like a 1.5 and 2.5. Those aren't going to get back to the same place.
So if you had, the number on the fraction has to be bigger than 2 if you're going to subtract or add.
If you're going to get a positive answer, you got to keep adding until you get into the positive numbers. Now this one, I only have to add 2 pi to get into the positive numbers. If I put a 1 under this and multiply it by 3 because I need a common denominator, that's just going to be 6 pi over 3. So negative 2 pi over 3 and a positive 6 pi over 3. When I put a negative 2 with a positive 6, I'm going to get a positive 4 pi over 3. That is a positive coterminal angle. Negative 2 pi over 3 and positive 4 pi over 3 are coterminal. They're going to be in the same position. They're going to both look identical. Now, when we get to the unit circle, you're going to see where they are and how they look identical. You're going to see that this negative angle here, negative 2 pi over 3, will be in the same place as positive 4 pi over 3. They'll both start at 0 and they'll both end in second quadrant, third quadrant. And then we need a negative 1, so I would take the negative 2 pi over 3 and I would subtract the 6 pi over 3 this time. Subtracting 2 pi is the same thing as 6 pi over 3. Now you're going to get negative 8 pi over 3. Those are still coterminal. So those two angles would still be in the same place, one extra rotation around. This negative 8 pi over 3 is more than a full rotation. It's more than a 2 pi. All right, that's coterminal. Let's look at complementary and supplementary. Complements and supplements. Complements and supplements. Now, you hopefully remember what complementary angles add up to. Add up to 90. Complements add up to 90. Okay, supplements add up to 180. If you took 90 degrees and did yesterday's assignment where you multiplied it by pi over 180 to convert it to radians, and you know that 90 goes into 180 2 times, you would get pi over 2 radians. So complementary angles, not only do they add up to 90 degrees, but they also add up to pi over 2 radians because that's the same as a right angle. Complementary means they add up to a right angle. So they add to a right angle. So whether the right angle is 90 degrees or whether the right angle is pi over 2 radians, they're both right angles. So complementary angles are going to add up to a right angle. Supplementary angles are going to add up to a straight line. So the straight line is 180 in degrees. The straight line is pi in radians. Pi is a straight line all the way across, half a circle. So your pi radians. So these examples down here say find the complement and supplement of those two angles. So let me ask you this. So let's think back to the last, chapters in geometry. I said, find the complement of like 70 degrees. What's the complement of 70? 20. How'd you get that? You took 90, you subtracted the 20 to see what was left over, right? And 20 was left over to be your complement. If I would have said find the supplement of 80, you would take 180, you'd minus 80, and what would be left over would be your 100, your supplement. So we want to do the same thing in radians. If I want a complementary angle, then I need to take my 90-degree angle, my right angle. My right angle is pi over 2. And I need to subtract my angle from it, 2 pi over 5. You know how to subtract fractions? Common denominator. What's my common denominator going to be? 10. So multiply the first one by 5. Multiply the second one by 2. So you're getting 5 pi over 10. And you're minusing 4 pi over 10. So when you subtract those two, you're just going to get 1 pi over 10. That's going to be your complement. Okay, so this right here was for complementary angles. You're going to take the 90-degree angle, the right angle, and subtract the angle from it to get a complement. So what does that tell me about 2 pi over 5 and pi over 10? What does it tell me if I put those two angles together? That makes a right angle. It'll be the right angle, 90 degrees or pi over 2 radians. So these two together will make a right angle. That's what it tells me. That 2 pi over 5 and that pi over 10 makes a right angle. What if I want to make a straight line? I would take pi and subtract the 2 pi over 5. Because pi is the same as 180. So if I want a straight line, I got to take the 180 and subtract from the 180. So pi is nice because it's a 1 in front. And if you need a common denominator, isn't 5/5 still going to equal 1? And now don't I have a common denominator? So yeah, that'll be much easier. You're going to get 3 pi over 5. That would be what we call the supplement. Okay, so this right here is for your supplementary angles. So complementary angles, you're subtracting from pi over 2. Supplementary angles, you're subtracting from pi. So that's a complement, that's a supplement. This angle plus the angle we had would give you a straight line. The pi over 10 plus the angle you had would give you a right angle. So let's try letter B. If I take pi over 2 and subtract 4 pi over 5, and again, I got to make them both 10s, so I got to multiply that one by 5 and that one by 2. So you get 5 pi over 10 minus 8 pi over 10. I end up with negative 3 pi over 10. Well, there was something I told you about complements earlier. I said 2 things have to be true about complements. They have to be acute, and they have to be positive. So what is that? That's negative. That breaks the rules. So you would just cross that out and put no complement. There is no complement because that angle's already bigger than 90. It already passed 90 degrees. It already passed the right angle. It went past the right angle, and now it's getting towards the straight line. It's not quite at the straight line yet, but it already passed the right angle. Now you've got your pi minus your 4 pi over 5. And again, you can put 5 pi over 5. You're going to get 1 pi over 5. That does have a supplement. It is not past the 180, so you do have a supplement. If it was past 180, you wouldn't have a complement or a supplement. If it's already in a reflex angle, you don't have any of them. But that one does have a supplement. So you'll have a few on the homework where it's going to ask you to find the complement and supplement. Yes? It has to be positive and it has to be acute. So less than a right angle. Supplement, it just has to be positive and less than 180 or less than a straight line. There is one last thing that I had up here that I didn't want to forget to show you. Degrees, minutes, seconds. Degrees are already small. Think of 1 degree on a circle. How small is 1 degree? Really small. Do you know that you could take that one little degree and break it up into 60 pieces? And they'd be called minutes. Yeah, I know minutes are time, but minutes are also degrees. If you take 1 degree and break it up into 60 little pieces, those are each a minute. And if you take each minute, now you're getting into microscopic things. But if you take each little minute and break it into 60 pieces, those are called seconds. Okay, so they're really, really tiny. So minutes are 1/60th of a degree. Seconds are 1/3600th of a degree. So if you want to convert from degrees to minutes and seconds, 40.45 degrees, you have 0 degrees, so you would keep the 0 in degrees. But the 0.45 you could convert into minutes and seconds. So you take the 0.45, which is a decimal, is 0.45. It's a fraction, is 45 hundredths. And you would say, how many, if I have 45 hundredths, how many would I have if it was out of 60? Because that's what minutes are broken up into. That's what degrees are broken into. So if I've got 45 hundredths, which is what this fraction says, then how many out of 60 would that make? And you could just do your cross multiplying. Or you could reduce early if you want to, but you could just cross multiply. You'll get 100x equals, and you do 45 times 60. And that's 2,700. And if you divide both sides by 100, that means you get 27 minutes. Minutes is 1 tick mark. Minutes lies like feet. It's like a 1 tick mark, but that's a minutes. Seconds are like inches. They got the 2 tick marks. So that would be 27 feet. That's how they got that one. So if you look at the second one here, 245 degrees is already written for you right there. This time they want you to go from minutes to decimals. They want you to go from minutes to decimals. This is even easier because 10 minutes is simply 10 out of 60. It's 10 minutes out of the total 60 minutes that you could have if you just simply divide those two numbers. So you take your calculator and you do 10 divided by 60, you'll get that 0.167. That's how they got that 0.167. That's how they got that. So if you just take the 10 minutes and divide it by 60 minutes, you're going to get your decimal. So if they wanted decimal degrees, then you're going to take the minutes divided by 60. Okay, if they want the decimal to become minutes, then you got to set up your little proportion and solve it. Okay, so let's try this last one we just did already. This one's already up there. So this was 245.167. Let's try this one though. You're going to take 15 and divide it by 60. You're going to take 12 and divide it by 3,600 because those are seconds. There's 3,600 of those seconds inside of a degree. So let's take the 15 and divide it by 60 first. That's 0.25. 0.25. And then let's take 12 and divide it by 3,600. That's going to be really tiny. 0.003. 0.003 with a bar on the 3. Goes on forever. Because these are seconds. It's like, you can almost think of it like hours. There's 60 minutes in an hour, and there's 60 seconds in a minute. So 60 times 60 would be the 3,600 seconds in the hour. So there's 3,600 seconds in a degree. So you're going to add these two together, which is going to be 0.253. You could keep the bar on the 3, and you're going to bring down the 125. So this would be your answer right there. So that's to convert it from the minutes and seconds to a decimal. So that's going to be on your homework tonight too. I just wanted to show you that. All right, that's enough for today.